All right, welcome all. Today, Sarag and I are actually going to be presenting a couple of things. One around the digital cadastre modernisation project, which is essentially a big undertaking that Land Victoria has done in improving the state's cadastral land base and the implications that has within Yarra Valley Water. And secondly, just want to highlight a new little cool little system we've implemented within Yarra Valley Water called Distribution Management System, or DMS for short. It's essentially a digital twin showing our customer impacts and live works that are occurring within our network. So just covering that off. Before I begin, very customary, just doing acknowledgement of country and saying Hurrana, which is welcome in the Wiradjuri language, and acknowledge the traditional owners of the land we all meet on today. So the agenda, as I alluded to, very quickly, just talk about Yarra Valley Water and who we are and what we manage. Getting into then the digital cadastre modernisation project, and a shout out to One Spatial and their assistance they have provided in supporting us in implementing a workaround that we've implemented to support the Land Victoria's DCM rollout. And then finally, just as I alluded to, the distribution management system, which we use to monitor our service calls and fieldworks. So who are we? So Yarra Valley Water, we're the largest of three Melbourne water retailers, primarily in Melbourne's east, and servicing over 4,000 square kilometres and over 2 million customers. We're providing, as seen there, hopefully nice clean water. And that's primarily our role. We essentially came out of the Border Works in 1995, and have subsequently been semi-privatised. We are fully government owned, but managed separately. So what I wanted to cover off first before I get started into the DCM project is just a bit of history and where our GIS information has come from. So back in the mid 80s to early 90s, there was a large exercise undertaken to actually digitize all our asset information. So that's all our water and sewer networks. That was done by digitising from hard copy plans all our asset information, and those plans actually contain both the cadastre and the location of our assets. Now, for metropolitan Melbourne, they were actually captured at that 1 to 1,000 scale for water and 1 to 500 for sewer. That means that, relatively speaking, the accuracy of our asset information is like plus or minus 50 centimetres, which is more than adequate for our needs. But for semi-rural areas, that was captured at 1 to 25,000 scale. And that semi-rural back in the 80s actually contained where, like, let's say our head office is, which is in Mitcham, and then other adjoining councils like Manningham. They were semi-rural back then. Now they're well and truly urbanised, but it's important to note that due to the fact that they were capped at 1 to 25,000, any 1 millimetre off in digitising, and we've certainly heard stories of late Friday afternoon sessions and things like that, and they were capturing, let's say, not as fluently as what a Monday morning would be. The accuracy of some of that asset information comes into play. But it's important to note that that relationship between the property boundary and those assets come into play. So long as we are maintaining that property to asset, which side the asset falls on in relation to those property boundaries, we're relatively okay. Another thing to shout out is that since the 1990s, majority of our asset information, particularly from as constructed information, is coming digitised from surveyors. So essentially, yeah, you're getting in that 10 centimetre accuracy frame. And that's important to note too when we go through and discuss the impacts of DCM. So what is DCM? So Digital Cadastre Modernisation Project. This is a $45 million investment from the state of Victoria in improving the accuracy of our state's boundary information. What the exercise has done is actually digitise well over 2 million separate parcels of land, and essentially it's one big giant jigsaw puzzle where every single title is one piece of the jigsaw puzzle, and when you bring all those jigsaw puzzles of the state of Victoria together, that's providing us with a far higher level of accuracy of our land base than we've ever had before. It's a fantastic investment for the future of Victorians' infrastructure projects and things like that, ensuring that we're making the right decisions upon that underlying land base. But how's that then play out within Yarra Valley Water's framework? And as that image there is showing, the green line is our existing cadastre. And what you see there within our existing cadastre, it doesn't really align to the fence boundaries, where the light blue boundary is the new DCM data. And it's actually better aligned to this, the parcel property fence lines and boundaries from an ortho-rectified photograph. And it's showing that there is a vast improvement in the land base within this particular region. It is like it does alter and change in different regions of the state, and whether it's urbanised or rural. But here you see an area where it certainly has been impacted, and the DCM data is certainly improving the accuracy of the of the state's land base. But important to note is the location of our asset information. What you see there, that I'll focus on that red dot. That red dot, which was primarily in that that top land parcel, is now falling on the adjacent land parcel. And that's the type of issue we need to go through and correct our data when we feel we need to, and I'll allude that in the next slide, correct our data so we maintain that property to asset relationship. So here's an example of what types of exercise we need to undertake within our data. So again, you'll see that the light blue cadastre there is the new improved DCM data. But and the green is the previous cadastre information. What you see there is that our asset information, in this case sewer, is actually falling outside of the existing land base, but inside of the new land base. And that's where we need to make the call to say, how is this data, this original asset data, being captured? Has it been digitised, or whether or not it's coming in from a survey accurate digital supplied data? Because depending on how that information has come into our environment depends on how we want to handle it. So let's say it was digitised. That means that that spatial to that asset to property boundary relationship needs to be maintained. In which case, we'll actually, and what actually will transpire in this case, we need to move that asset down so it's falling outside that property base. There will be other times where that is survey accurate, and we'll just keep it where that survey accurate data information has been provided. And it just means that the existing land base actually maintain that asset property relationship incorrectly. And we've certainly seen some like that. But it highlights that we can't actually automate this whole asset correction ability. We need to manually go through. And that means we needed to come up with a way to, one, support the ongoing development that occurs within our land base when new subdivisions get released every week. But while we also need to go through and correct our asset information. And so from that, I'll throw to Sarag to explain the workaround that we implemented. Oh, prior to doing that, the other important thing I will call out is that we have a system called Easy Access. And that Easy Access actually has automation within our GIS that ascertains whether or not there's an asset associated to a property. And Easy Access allows for developers and or like homeowners to put in an application, and those applications could be a subdivision subdividing a parcel of land and or build a build over, putting a shed or a pool in a backyard. We need to grant approval for any of those development applications that may or may not be impacted by our assets. And the way we do that now is we do it through automation, where in the back end, we're running web services to interrogate our asset data in relation to the property and return whether or not an asset exists and what type of asset exists. And on the basis of that, we've been able to automate over 80% of our development applications every year. So it's critical that we maintain that asset to property relationship to support systems like easy access. In addition, we have on any sale of a property, you have within the section 32, you have asset plans being created, and those asset plans are used by conveyancers and property owners that actually want to subdivide or have future plans for a property. Again, they'll actually look at that plan and ascertain whether or not an asset exists in the backyard, because that may actually factor into their decision on whether or not to purchase a property. So those things, it's critical for the support of those plan sales that we maintain that asset property relationship. Now, I'll throw to Chirag to explain the workaround that we've done to support DCM.
All right. Thank you, Charles. That was excellent explanation about the DCM and its impact to Yarra Valley water. So I shall also give a lot of credit to Charles to think about this workaround, and I might just going to explain it to you now. So what happens to Yarra Valley water? We have about 17 councils partially or completely within Yarra Valley water's catchment, and 10 of them have already been integrated into DCM. 3 are planned by end of July this year, and 4 later in the year. So there are lots of councils to cover and massive data to adjust. So what happens in DCM? That a week prior to the DCM integration, Land Victoria or DALP, they will stop doing any updates to their property base. So that week there is change freeze, and the following week, when the actual change happens, the DCM integration is rolled out. Now, Yarra Valley Water consumes the WICMAP data through IUF process. So we have our own IUF import tool, which takes all these 17 councils and pull all the WICMAP data into our WICMAP schema and updates the map base. So on the week of integration, we pause the import for the council getting integrated into DCM, and we let other 16 councils go through our normal process. And we use FME process to strip out the geometry of the DCM council and then just import the attributes. So as you all know, PFI is the identifier which remains constant for the life of any WICMAP object. So that you can see in the image 1 and 2, the PFI remain constant of 13, and UFI, which is every new change gets a new identifier. So which is called unique feature identifier, I guess. So when the DCM happens, the UFI changes, and that is captured through that FME extract I was talking about and imported into our database, but not geometry. The subsequent week, we let IUF load that council into our GIS database. Now, you can see that week 2 picture there, the land base, which is the property at 11 or PFI 13, is now subdivided into 2 properties, and they get now 2 new PFIs and 2 new UFIs, replacing the PFI at 13. So that is slightly out of whack from the original CAD base. because we didn't implement the DCM, it is going to sit a little bit offset from property at number 9. Charles, can you please go to the next slide for me? Thank you. And this is how the impact looks like. So for our normal CAD base, where just before Charles explained how easy access makes the decisions automatically based on where the asset sits within the property, etc., it is still considering the scenario on the left, whereas on the right is how the cadastre has moved. And there's a small impact, but it is covered with a lot of business communication internally and externally, also added to our disclaimers. So people are aware of the Yarra Valley water is catching up with all the asset movement into the right area. And for the time being, they will have to be informed with this sort of anomalies. Go to the next slide, please, Charles. Now, this is where One Spatial comes into play. So Priyantha and James, though they are not here today, they are from New South Wales and Western Australia. They've helped us in creating this process. So what it does is takes the IUF, where the DCM is integrated for that week. It strips out the geometry. It creates the extract of all the attributes and also creates Oracle script for us to import into our database. And you can see that on the right bottom corner. So that's the script we get, and we use our Oracle tool to import all these attributes into our GIS database, and everything gets updated. Thankfully, we were not on the bleeding edge, and Hobson's Bay Council or Queenscliff Council, they were outside Yarra Valley Water who had to go and through DCM before. So we had a bit of time to actually prepare and get in time for our first council, which was Nilambik back then, to get integrated into our WICMAP schema. I think that, yeah, and this is how I think I explained to you the top bit where how things happened a week prior, a week of the DCM and week after DCM. Then what happens once the data comes in, we review that. It's not that DCM is 100% accurate all the time. We do the quality check as well on it. And if there are any anomalies, we send it back to WICMAP and tell them to address those. And then we also consider how much asset impact we have. Sometimes there is a very small impact, sometimes no impact. And then we create a list of things to adjust. And then for that council, we will be adjusting the water and sewer assets. Once that is all done, that council is all assets reconciled, then we implement DCM. We haven't been to that stage yet because you can imagine it is a massive impact for us. Sometimes each council have over thousands of assets to move, so it takes time. So we are slowly getting there, but hopefully eventually we'll be able to implement the DCM through seed files. And I think that's about me, and I'll hand it over to Charles again. Thank you, Charles.
Thank you, Surag. That was excellent. And just a shout out, as Surag mentioned, the what support we received at late notice from One Spatial was certainly appreciated, and we've been able to implement this workaround internally, and allows the business as usual to activities to progress while we go through and actually update our asset data. As I alluded to, I also want to do a quick little demo of a new little tool we have within Yarra Valley Water, which is called Distribution Management System, and giving you appreciation of what it's doing. So firstly, we have actually approximately 80 different field service business partners. So contractors going out and doing works upon our assets. They're completing 100 plus different types of field activities, being it water quality results, being it planned maintenance, reactive maintenance, and or inserting new assets and things like that, installing IoT sensors. All that field works are being undertaken on any given day. and that sort of is estimated over 400 people plus are working on our assets on any given day. And we needed a way of visualizing where those works are occurring, the customer impacts associated to those works, and allowing different sections of the business to understand what other works are being undertaken within a particular region. And how those works may be impacting customers. For example, you may have some sewer works being undertaken, planned sewer works to do a sewer reline. You've got some traffic control being undertaken, and unbeknownst to you, there's a water burst happened just around the corner, and it's got its own traffic management, and that scenario is then playing out where it's just chaos for any traffic within that area. So what that makes us get awareness of now is that type of scenario playing out, and this system gives us alerts that can notify us, and we can intervene. And let's say for the planned works, we can delay that for a couple of weeks while the emergency works get undertaken. And it just provides us a far better tool in understanding the operational state of our network. If we look at the architecture, what we've been able to do is bring in what's been built to date, is bring in all the GIS asset information into our DMS. We have Maximo as our asset management system, which manages both the customer calls that come in relation to works, i.e. service faults or low pressures or water quality issues. And then also manage the field works that are undertaken, those work orders associated to those day-to-day activities. Those work orders may be planned, i.e. a couple of weeks in advance and or further into the future. Or we actually may want to have a look at a scenario that occurred a couple of weeks ago, which had customer impacts and have some learnings around it. This tool allows us to actually go forward and back in relation in time, but actually provides near real-time information on what's actually occurring on the network. And as I alluded to too, we're bringing in water quality results at every given day. We do over about 150 water quality sample results, and we can see those results and have alerts and in the system where those results may be coming and showing there's an anomaly. In the future, the section of grey is, as I alluded to, the IoT, the Internet of Things to come. We're bringing in a lot more pressure sensors, water quality sensors, sewer level monitoring, could be external sensors like Bureau of Meteorology. All this information can now be incorporated into DMS and allows us to put those business rules on that information and be more reactive to what's actually occurring in the network. So what I want to do is just actually quickly go through and give you a quick demo of the system. This is the actual system itself. Just quickly highlighting what it's showing there. This is Yarra Valley Waters region. In the orange are emergency works that are currently being undertaken, and the purple are planned works that are currently being undertaken, and the green dots there are service calls. These are customer calls in relation to faults that are occurring that gives us more insight into what's actually occurring. Up the top are some just high-level dashboards showing the number of water off properties, so properties without water currently, number of service requests, so number of customer calls that we've received in relation to faults and issues today, and that's 400. And then the number of active work orders that are actually still yet to be closed and being undertaken. What this system allows us to do is actually apply filters to actually get an insight into the types of information. And what I will call out is that it's got a very easy and responsive way to apply filters. So I can just say here, just show me priority 1, priority 2 work orders, and they're going to be the high priorities, and automatically the underlying data gets updated. So it's a different way of doing filters, or I can actually just close this off and show you predefined filters. So I've got some saved filters here, And if I click on this, what this is showing is currently properties or work orders that are being undertaken where there's customers without water. And here there's a couple, well, three in fact. These two here I relate to emergency works, and the purple is in relation to planned works. I can zoom into that given area. And what you see when you zoom into that particular area is the customers that are actually being impacted by those works. I can click in here and I can see that there's currently 37 properties that are impacted. I can go into the details on that and see in the logs, and these are the field work crew actually working on it, their notes, what's the current status. I can actually go and look at the timeline, and from a customer call perspective, if we're getting any calls from within this region, they can say, look, you're scheduled to have water turned on at this given time. And it also allows you just to select on the particular customer itself. It's got the Google Maps view of the world. And there's a number of other activities that does show water quality results here. So I can come into this and click on that little drop there. And it's highlighting the longer term water quality results, or if I just want to see the most recent results, and I can see what were the results of that water quality was. So really wanted just to give you a quick snapshot of our digital twin in relation to customer calls and work orders, and giving you an appreciation of a new tool that we have within Yarra Valley Water. Thank you for your time, and thanks for your attention.